Hello everyone. So in this video I'll be explaining you few of the example problems related to frictions. So before solving the problems you must be aware of the condition of equilibrium and its application with respect to horizontal axis and vertical axis. And along with this you must be very careful about considering the sign conventions for the forces based on the direction, whether it is moving in upward direction or downward direction or towards right direction or towards left direction. So respective sign conventions has to be taken into consideration. Now let us move on to the first problem. So a block as shown in figure is just moved by a force of 200 Newton. The weight of the block is 600 Newton. Determine the coefficient of static friction between the block and the floor. So this is the given figure wherein a block of 600 Newton has been placed on a horizontal plane. So a 200 Newton force is being applied and it tends to move the block towards right side. So this force is applied at an angle of 20 degree with respect to the horizontal. Next let us consider the free body diagram of this block. So with respect to this block, 600 Newton will be acting in downward direction, that is the self weight of the block. The 200 Newton is acting towards right direction as per the given figure. So as the block tends to move towards right side, the frictional force will be developed in the opposite direction, that is towards left side. So this N represents the normal reaction as the block is in contact with the surface at the bottom. So here he is giving the frictional force is equal to mu into N. So this is defined by the coefficient of friction mu is equal to F by N. So now applying the condition of equilibrium along the horizontal axis, that is x axis, that is sigma Fx equal to 0. So which are all the forces acting along x axis? One is 200 Newton. So the horizontal component of this 200 Newton is 200 cos 20 degree. Next is frictional force F, which is acting towards left direction, which is equal to mu into N. So as it is acting towards left direction, he is taking this as negative. So either you can take this as positive and you can consider this 200 as negative. So both can be acceptable. Next is applying the condition of equilibrium along y-axis, that is sigma Fy equal to 0. So which are all the forces acting in the vertical direction? First is the normal reaction N acting in upward direction. So N taking as positive. Next 600 Newton acting in downward direction. So it will be taken as minus 600 Newton. Next is the vertical component of this 200 Newton, which will be acting in upward direction, which is equal to 200 sine 20 degree, which is positive. So further if you simplify this, N will be equal to 531.59 Newton. So further if you solve this equation 1 and 2, we will be getting the value of the coefficient of friction mu is equal to 0.35. So before going to the next problem, I would like to explain one of the concept, that is when the block is in impending motion. So what do you mean by impending motion? So impending motion refers to that when the block is at the verge of sliding down or sliding upward. So here impending motion up the plane. So this represents that the block is tending to move in the upward direction due to the force applied. So here we have a block of self weight W and a force P is being applied. So as it tends to move, that is impending motion up the plane, as it tends to move in the upward direction, the frictional force will be acting in downward direction. Now the second case is impending motion down the plane. That means the block tends to move in the downward direction. So here if you observe, the force is applied in upward direction only. But even though the force is acting in upward direction, due to its self weight and the angle of inclination, the block tends to move in downward direction. So as it tends to move in downward direction, the frictional force in this case will be acting in upward direction. So this is very important. Whenever there is a question with respect to impending motion has been mentioned, you need to consider both the cases, that is impending motion up the plane and impending motion down the plane. So considering both the cases, you need to find out the respective values which has been asked for. Now let us move on to second example. A block of mass 20 kg placed on an inclined plane as shown in figure. It is subjected to a force P that is parallel to the plane. Taking the inclination of the plane with respect to horizontal as 30 degree and the coefficient of friction as 0.24, determine the value of P for impending motion of the block. So in this problem, he has given a block wherein a force of P has been applied, and this block has been placed on an inclined plane which is inclined to the horizontal and 30 degree. And also he has mentioned that this force P is parallel to this plane. He is asking us to determine the value of P for impending motion of the block. So that means we need to consider impending motion up the plane and impending motion down the plane. In both the cases, we need to find the value of P. Okay, now let us consider case 1, that is finding out the value of P for impending motion down the plane. So here we have taken the given figure and we will be considering this inclined plane as our x-axis and the line perpendicular to this as y-axis. So the block self weight is given as 20 kg and it will be converted into Newton by multiplying it with 9.81. So this self weight will be always acting in the downward direction. So as this P is acting in upward direction and he says that the block is tending to move in downward direction, the force, that is the frictional force, will be acting in the direction opposite to that of the movement of the block. So how it is moving? It is moving in downward direction. So frictional force will be in opposite direction. And this is the normal reaction as this block is in contact with this inclined plane. In this figure, the inclined plane has been considered as x-axis and the line perpendicular to this is considered as y-axis. So with respect to this, the parallel forces acting are P, F, and these are all the forces in x-axis direction, and N is acting in vertical direction, and this 20 into 9.81 is inclined to y-axis with respect to 30 degree. So how it is 30 degree? Okay, so here theta is equal to 30 degree, and if I extend the self weight so that it touches the horizontal plane, so it is at 90 degree. The alpha value will be now equal to 90 minus theta, so that is 30 degree. So this becomes my opposite angle, which is nothing but alpha equal to 90 minus theta. So this now will be the value of 90 minus alpha value, which will be equal to 30 degree. So that is how we have arrived at the angle of inclination of this self weight with respect to this vertical axis. Now we have identified which are all those forces which is acting in vertical direction and which are those forces acting in horizontal direction and the forces which are inclined to the vertical axis. So now let us apply the condition of equilibrium along y-axis, that is sigma Fy equal to 0. So here the forces acting in vertical direction are, first one is the self weight 20 into 9.81, as it is inclined at 30 degree. So this vertical component will be equal to 20 into 9.81 into cos 30 degree. And next force is the normal reaction. It is acting in upward direction and he is taking this as negative. So even here we can take this as positive and this as negative. So it is depends on your comfort. So both are acceptable. So now the N value is equal to 169.914 Newton. Next, applying the condition of equilibrium along x-axis. So the forces which are acting along x-axis are the frictional force, the applied force P, which has to be determined, and the horizontal component of this self weight, that is 20 into 9.81 into sine 30 degree. So with respect to the figure, it is minus P minus 0.24 into 169.914 plus 20 into 9.81 sine 30 degree. So further if you simplify this, you'll be getting the value of P, which is equal to 57.32 Newton. So this is the force that has to be applied for case 1. So the P value for impending motion down the plane will be equal to 57.32 Newton. Now let us move on to second case, that is to identify the value of P when the impending motion is up the plane. That means here when the block is tending to move in the upward direction, what is the value of P? So as the block is move in the upward direction, here in this case the frictional force is acting in downward direction. So if you observe the previous figure, the frictional force was acting in upward direction. Why? Because the block was moving in downward direction. So here in this case the block is moving in upward direction, the frictional force is acting in downward direction. Now again for this figure we will be applying the condition of equilibrium, that is sigma Fy equal to 0, and we will be getting the value of n, and sigma Fx equal to 0. Here we need to be careful about the value of F because there is a change in direction. So once you simplify this, the P value will be equal to 138.8 Newton. So when the impending motion up the plane, the P must be equal to 138.8 Newton. Okay, now let us consider the next example. A block of weight 1500 Newton rests on an inclined plane 20 degree to the horizontal as shown in figure. If mu is equal to 0.3, find the force required to push the block up the plane when the line of action of force makes an angle of 30 degree with the plane. So here is the given figure. He says that a block has been placed at an inclined plane. So this is inclined at an angle of 20 degree to this horizontal. So the force is being applied to this block so that the block tends to move in the upward direction, and this force is inclined at an angle of 30 degree. So now the problem will be solved in the same procedure as we solved in case of impending motion, but we need to be very careful while considering this value of P for while applying the condition of equilibrium. Okay, now let us consider the free body diagram of this figure. The inclined plane is considered as x-axis and the perpendicular line will be taking as y-axis. So here we have a self weight which is acting at an angle of inclination of 20 degree with respect to this vertical axis, and this force applied, and it is inclined at an angle of 30 degree to this horizontal, that is x-axis, and the frictional force acting in downward direction which is equal to mu into n, that is 0.3 times of n, and one more is the normal reaction which is acting in vertical direction. Now for this free body diagram we will be applying the condition of equilibrium, that is sigma Fy equal to 0. So the forces acting in the vertical direction are the vertical component of this force P, that is P sine 30 degree, which will be acting in downward direction, that is minus P sine 30 degree, and the vertical component of this 1500 Newton, 1500 into 20 degree, that is minus. Next, the last is the normal reaction which is acting in upward direction, plus n equal to 0. So further if you simplify this, we will be getting n equal to 0.5 times of P plus 1409.53. So this will be our equation 1. Next, applying the condition of equilibrium for the horizontal axis, that is x-axis. So the forces acting in horizontal direction or x direction are, so the horizontal component of this P, that is P cos 30 plus, next the horizontal component of this 1500, that is minus 1500 sine 20 degree, the frictional force which is acting horizontal minus 0.3 times of n. So here in place of n we will be substituting this value, that is 0.5 times of P plus 1409.53. So further if you simplify this, we will be getting the value of P equal to 1307.11 Newton. So here as per the question, in order to make sure that the blocks move in the upward direction, the value of P must be equal to 1307.11. So in such problems, we must be very careful about the angle of inclination of the force applied. It is very important.